Here are the answers to worksheet 2 for those at home, just so you can make sure that step 1, which is the oxidation numbers, and step 2, which is the bridges, are correct. Okay? And then where we're working to is, remember, a balanced net reaction. Now last week we could write a balanced net reaction by going to your data booklet and taking the half reaction of the strongest and taking the half reaction of the other strongest and then balancing electrons and then writing your net. Remember that? It's the same thing, only what if we can't look up the half reactions? Okay? And we can't balance using Science 10. Now we have to do some fancier balancing moves, some fancier half reactions, and that's what this is about. But in principle, it's the same thing. I'm going to have the number of gain of electrons equal the number of loss of electrons. You can see on question 2 that they are equal at the moment, right? But Cl, let me just write this like we would have, I don't know, at the beginning of the unit. Cl2 becomes what? Cl minus, right? Now just don't think about this for a second. How did it become Cl minus? This is like the first thing you did in this unit. It must have gained an electron. And I have 2 Cl's, right? Oh, just a minute. Gain an electron. Oh, look. Gain an electron. That's what you said. Because the oxidation number changed from 0 to -1. So it gained an electron. What gained an electron? Each atom. Each Cl. But how many Cl's have I got? 2 Cl's. So therefore I must form 2 Cl minuses, and therefore each of them gain an electron, so therefore 2 electrons are gained in total. Okay? So step 3 is about, hey, now that you've done the bridges, and you know that you've gained 1 electron per atom, tell me how many electrons you gain per, I'm going to use the word compound, although Cl2 isn't really a compound, it's a molecule, but you know, per, I'm supposed to say, per formula unit. But that's going to confuse you even more, right? So I'm going to say per compound. You know, that's not really a compound. It's compound. It has to be 2 different things. Anyway, you get what I mean. Okay? So per group, how many Cl's have I got? 2. So therefore, how many electrons have I really gained? Not 1, but 2 electrons. Does that make sense? Okay, so that's the next step that we're going to do. Okay, so step 1, oxidation numbers. Step 2, bridges. That's per atom. So what about per molecule? So times 2. Okay. And then the next thing that we're going to do is we are going to look at our loss and gain now, because you finally finished that proper half reaction. So now I have 1 half reaction and the other half reaction. So I have 2 electrons gained here and only 1 electron lost. See that? And back to our cafeteria, if one thing's being gained and the other thing's being lost, sorry, I'm just going to do that. If one thing's being gained and the other thing's being lost and they don't balance, it doesn't make sense. So I have to multiply this by 2, just like I would have down there. Okay? And then the next thing that you have to do is you take these multiplication numbers and bring them down. So take your timeses. So here's the times and here's the times. So I have 2 electrons gained and 2 electrons lost, so those equal. That's what I have to end with on my bridges. And I'm going to take these big numbers and put a 2 there. Oh, I already have 2. And a 2 on the other side of the bridge. Oh, that's where that 2 came from. So your one wouldn't have been balanced. And then here I have to have 2. So over here, oh, that's where this 2 comes from. And, oh, that's already a 2 there. And now it balances. I know you could have done it Science 10-wise. I know that. Right? But at first when you're learning algebra, you learn 2x equals 12. Solve for x. And they make you divide both sides by 2. And you have to communicate it going like this. And therefore x equals 6. and you're sitting in the class going, it's pretty obvious. Why do I have to do all that little stuff? And because now you know that the algebra that you end up doing is crazy. So you have to learn the skill behind it, right? So that's what this is. It's learning the skill behind it with quite an easy example. Okay, just to show you they are the same. They link. Okay? Then there's one more step to make sure the charges are balanced. Because in Science 10, we don't really deal with ions. So when we're balancing, and we've done this a little bit last week, right? When we're balancing, we don't have to worry about balancing charges. But let's just make sure the charge on the left-hand side of the arrow equals the charge on the right-hand side of the arrow. Neutral, 2 negatives. So in total, -2. This side, 2 negatives. Neutral. So therefore, total, -2. Yay. It won't always be a yay, though. We're going to discuss what to do with it. Do you get what we're doing today? Okay, so in your package that I've just handed out to you, which looks like this one? Nope. This one. Using oxidation numbers to balance. Okay. So sometimes we write our net reaction by creating the half fractions ourselves, where you can just see it's quite obvious that I've gone from, I don't know, aluminum to aluminum 3+, and I must have done that by losing 3 electrons. Right? You don't have to go to the data booklet for that. So that's the first way that we learned how to write a net equation. The second way we learned how to write a net equation was using your data booklet and getting those half reactions from the data booklet. This is now the third way of writing a net equation. Do you understand? And you need to be able to do all 3 ways proficiently, because if they don't give it to you in the data booklet, and if it's too tricky to do it on your own, you have to do it this way. Okay? And if it's easy to do on your own, it's faster to do it that way. But you could technically do it any of the ways. Okay? Okay, so net equations are easily balanced, have reactions. That's what I've just basically said. So the first thing we're going to do is we're going to assign oxidation numbers to all the species. Easy. Hopefully. Then we're going to identify the change in loss or gain of the electrons. This are the bridges that you just did on worksheet 2. Okay? And the bridges told you per atom or ion. So in other words, the Cl only gained 1 electron each per atom. And then we need to beef it up, bring it up, expand it, so that it's not just per atom, but rather per compound or molecule or whatever. What's the matter? Okay. Then you're going to balance the number of electrons per formula unit. What I mean by that is number of electrons lost must equal the number of electrons gained. Okay, Gabby? Number 3 means number of electrons lost equals the number of electrons gained. Okay? And you've done this in a variety of different ways. It's the same thing, just different. Then we're going to transfer all the multiplications that we do. We're going to transfer them to the reactant, like at the end of the bridges. Then you're going to balance the rest by site. That means like Science 10 balancing. Okay? Science 10. Except oxygen and hydrogen. So this means Science 10 balancing. Except oxygen and hydrogen. Okay? Now before we get into the oxygen and hydrogen, sort of what to do with them, let's just master these steps here. So, with this example. Now I know you can balance this using Science 10. I know you can balance this at the very beginning of this unit using your making up yourself half reactions. You should be able to see that this is Ag plus, and it's becoming Ag solid, and it must have gained 1 electron to do that. I don't think you need to do the oxidation numbers to solve for that. Everybody agree with that? So, at the very beginning of this unit, you already learned how to write 2 half reactions and the net reaction for this. My point isn't that you don't know how to do it that way. My point is that you end up with the same answer. Okay? So, oxidation numbers. Ba-da-da-la-la. What's changed? Well, Ag, so let's do our bridges. Ag has gone from +1 to negative, which is 0. The number is reduced, so therefore the species is reduced. So it must have gained 1 electron because it went from 1 to 0. Everybody happy with that line? It's the same thing as the worksheet we just finished. Okay, right. The aluminum is the next thing that changes. The aluminum goes from 0 to +3. The number goes up, so it's oxidized. That means loss of 3 electrons. Okay? Then that's per atom, so the next step is to look at it per compound. I've got 2 Ags. So each one is gaining 1, so therefore the compound, what I've thrown in, because there's 2 of them, must be gaining 2. Everybody with me so far? This, there's only 1 that I throw in, so it's only losing 3 electrons. And now I've got 1 half reaction, and I've got another half reaction. Finished. So now I have to look at the number gained and the number lost equaling each other. So I've got 2 gained and 3 lost. So I need to multiply this by 3 to get 6 electrons gained in total. And I have to multiply this by 2 to get 6 electrons lost in total. So the blue is about having the number lost and gained equal. So this blue bit is about what you would have taken your half reaction and multiplied it by, because it says plus 2 electrons, and this one down here says plus 3 electrons, and so I've multiplied that one by 2 and this one by 3. So the blue is about this, like you did last week. Okay? And then the last step is to bring those multiplications up the bridges. So here I have a ×2 and a ×3. So you look for your times numbers. I've got a ×2 and a ×3. So I took the original, I multiplied it by 2, and I multiplied it by 3 after that. So that means a total of 6. So I want 6 Ags. I want 6 Ags. So following that bridge up, I can find my first Ag. And I need 6 of them, so that means I need a 3 here. 3 and 2 is 6. Okay, my goal is to get 6 Ags, 3 times 2. Over here, my goal is to get 6 Ags, so 6 Ags. What's the goal on this line? ×2. So I want 2 ALs. So follow up, I want 2 ALs, so 2, I want 2 ALs, or I already have 2. Bless you. Okay. Check with Science 10. I'm done, by the way, that's it. Right, that's the end. So just check with Science 10. Like you would have balanced that in Science 10. Could you balance that in grade 10? Absolutely you could have. It would have been like a normal question on your exam. So let's just check. 6 AGs, 6 AGs, 3 S's, 3 S's, 2 ALs, 2 ALs. Done. Just like you would have in Science 10. Okay? Did you get it? Okay, so why bother teaching it this way if you could do it in Science 10? Well, that's because in Science 10 we didn't give you any ones that you couldn't balance. Right? And as we go through this sheet, you'll see questions on the sheet that there's no way I would have given you this. Oh, by the way, this says COOH, okay? There is no way I would have given you this equation to balance in Science 10. Do you agree with that? Because there's no charges in Science 10. I don't acidify a solution. So I wouldn't have ever asked you to balance this in Science 10. So we have to use our oxidation numbers in order to balance them. Okay? In fact, if ethanol is in your data booklet, you don't even need to use this method. You could use your data booklet method, where you write down, and multiply, and get your net. As long as this is in there, and you know that these two go together. Your species involved are here, here, and here. Right? So you could do the data booklet method for this if ethanol's in there. I don't think it is. So you're going to have to do the oxidation numbers. You can't do it Science 10. You can't make up your own. You can't do it by the data book because this isn't in there. As long, you've looked hard and wide, and all you can find is your strongest oxidizing agent. You can't find a reducing agent. And therefore, you're going to have to do it this third way. So oxidation numbers, they're all up there, all for you, ready to go. Okay? And so what has changed? This, by the way, is a 6.
So CR has changed.
So has CR changed? And so you would have done your bridge yesterday on the thing, and you would have said that the number is reduced. So therefore this species is reduced. And therefore it's a gain of how many electrons?
3.
Good. And the other thing that changed was carbon went from -2 to 0. By the way, the other carbon in there is a 0. It doesn't matter what carbon you draw into. And therefore this is a oxidation, which is a loss of
4.
no.
2.
2. Look at your base number, base number, base number. So one of the questions could very well be to stop there. So use the following information to answer the next 3 questions. Question number 1. The reducing agent has lost how many electrons? You're saying 2. Okay? This because they make it even more. They would say the atom. The atom has lost how many electrons? The atom has gone from negative to, or how did the oxidation number change? And it'd be from -2 to 0, not 4. It's 4 because you have 2 of them. Okay? So, loss of 2 electrons. Everybody okay with that? That's step 1 and step 2. Step 1 with the oxidation numbers, step 2 being these bridges. Step 3 was now to look at it per compound. So 2, so therefore if each atom gained 3, then in total I've gained 6 electrons. And here also a 2. So therefore times 2. So each atom gained 2. So therefore each compound gains 4. Are you thinking, but I ended up with the same answer as you? But then you wouldn't have this times 2.
No, I understand that. Yeah.
Okay, perfect. Okay, then
You have to go and put it up top.
not yet. Balance the electrons. The step everyone forgets. Balance electrons. 6 gained, 4 lost. So if I multiply this by 3, I will get 12 electrons lost. And if I multiply this by 2, I will get 12 electrons gained. Your lowest common multiple. Is that what that's called? And now, bring it up. Times 2 and times 2. So I want 4 chromiums. So therefore, uh-oh, no. Good. Well done, those you said 2. Okay, but over on the other side, 4. Okay. This one, times 2 and times 3, so that makes 6. Do you add or do you multiply? Multiply, right? 6. Why? Because you'll ask yourself that tomorrow, probably. Okay, so multiply. So 6, so you got to have 6, so bring 6 up here and you get 3, and bring 6 over here and you get, oh yes, there's already 2 there, so therefore I want 3 as well.
So you don't have to worry about balancing the rest of it though?
Just a minute. You do have to worry about that. Everybody happy with all the colors on the board? Where I got everything from? Okay, that was step 1 to 5. Now you take a step back, and Nick's gone, you don't have to worry about anything else there? Well, chromiums 4 and 4, good. Carbons 6 and 6, good. Hydrogens, whoa, not so good. Oxygens, not good either. Remember that line that said balance for science 10 except for hydrogen and oxygen? Remember that? Okay. So this is how you fix your hydrogen and oxygen. So balance for science 10 except for hydrogen and oxygen. Everything okay up there for science 10? Except for hydrogen and oxygen? Good, okay. So how you balance your hydrogen and oxygen is step 6, which is somewhere up there, but I don't want to scroll it down because then I'll lose all my places. It says balance the charge. This guy here is going to help us balance the charge. Okay? So, because if I touch anything, okay, so what's the charge on this side?
2.
What's the charge on the right?
4. 6.
What's the charge of this compound?
It's 2, so that'd be 6. 1. 11.
Neutral. The charge on that compound? Neutral. How many have I got? 3. So I've got 3 neutrals. Charge on that compound? Neutral. Charge on this compound? Or, pardon me, it's not a compound. The charge on this species? 3 plus. How many of these have I got?
4.
So what's my charge on this whole side now? 12 plus. I've got 4 3 pluses, so that makes it 12 plus on that side of the arrow. And neutral and neutral, so 12 pluses. Are you okay with that? I don't want to play with this, okay? If I change this 4, that messes my whole bridge thing, and this is perfectly balanced at the moment. So I don't want to touch that 4, okay? So 12 has got to stay 12. On this side, I don't want to touch this 2 either. So how many have I got in this situation here? Just here, this bit here. -4. I've got 2 2 minuses. I've got 2 2 minuses. So I've got -4. This thing here, which I also don't want to touch, is neutral.
So you just have to put a 3.
So this I don't mind touching because right now I haven't done anything with it. So if I change it, it won't change anything else. So I'm going to use that to get this side to equal +12. Okay? What number?
3.
Positive 16. Then that side equals positive 12, and that side equals positive 12, and my charges are balanced. So I'm going to put 16 H pluses. That's step 6. You happy? But by the way, for those of you that know the chromium half reactions in your data booklet, it involves 8 H pluses in your data booklet. So therefore, if I have 2 of them, I'm going to have 16. So it works out as well. Okay, they're all linked, not different. Well, it is different, but I mean they're all much the same.
So this is basically then a reaction of 2 things combined.
Right, absolutely.
Except the one's not in there.
Right, one's not in your data booklets. You have to choose to do it this way. Okay, bubbles. Okay, and then the last step that's written above here, step 7, is to, after balance the charges, is to balance the hydrogen and oxygens finally, and we're going to use this water to do that, because the water's untouched as well. Okay? So, because I don't want to play with this, I don't want to play with that, I want to play with this. These are, like, touch anything, it's going to mess it all up. But this, I can use that. So, how many waters am I going to need? Well, look at my hydrogens. I've got 16 hydrogens here, and I've got 6 times 3, 18 hydrogens there. So I've got 16 plus 18, which equals 24 hydrogens. 34. On the left. Oh, 34, thank you. On this side, I don't want to touch the fact that I've got 4 times 3, which is 12 hydrogens. Okay, I want it to equal 34, so how many hydrogens do I have left to account for? 22 within my H2, so that means 11 waters to make 22 and 12. 34 hydrogens on that side. Were you capable of doing that in Science 10? No. This is why we have to learn this new way of balancing equations. As smart as you were, you didn't know about balancing charges and how to fix that. Okay? Ha 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 ha. Okay?
So then the oxygens are automatically balanced.
Yeah, you can add up your oxygens to double check, but they will work out. If you've done it all right, they will be balanced as well. Okay? Going back to an easy question, number 2 here. Start doing your bridges and oxidation numbers, and you put your head down and start working, and I will start writing, and you look up when you're ready and see if you've done it right. Gabby, oxidation numbers.
Yeah.
Number 2, go. Are you done your oxidation numbers? They're all ionic compounds, so it's just a matter of reversing crisscrosses, right?
Oh, yeah, that's true.
Oh, yeah, that's true.
Oh.
Reverse crisscross. Works out the same way, just takes you a lot shorter of a time.
So you just reverse them? Does that work for most compounds, or?
Well, it won't work for this one because it's an element, so it has to be a 0. But yeah, for simple compounds like that, absolutely. And it doesn't matter because I don't use those top ones ever. I only use them to figure out the bottom charge, right?
So you're always using the starting number and the starting thing in the equation.
That's right.
for the one on the left, then the red on the right, you just have to find what it is in an equation.
Sorry, say that again?
So for like V, if say it was O5V2, then you just have to go to the V and you just find it.
Yes.
Okay.
To figure out which one is changed,
Yeah,
you mean?
yeah.
Yeah. Remember, if the number itself is reduced, then it is reduced and gains electrons. Huh? Good. What's up, Alyssa? Yeah. The more you do this, the better you'll be. It doesn't feel very innate. The steps don't really tend to flow into each other. You just gotta remember it.
So in the loss of 3 electrons, the times 2 part came from the V2 on the right side of the equation, correct?
Which color, sorry?
The
The red,
yeah.
the red times 2?
Yeah,
That came because I wanted the 6 electrons to
Okay.
equal these 6 electrons.
Okay. So then the 2 came from the V2 on that side? And
Right.
then,
No.
no?
So I did the black first.
Mhm.
That's yesterday's work.
Okay.
Then I said, right, little numbers. Oh, I only have 1 there, so that doesn't change. I've got 2 there, so times 2. So now I have 2 electrons gained,
Mm-hmm.
and I'm comparing those 2 electrons gained to the 3 that I've lost.
Okay.
And I need to make the lost and gained balance.
Okay.
So my red is about making the lost and gained equal, 6 and 6.
Alright.
So I got 2 because I want it to become 6.
Right. Okay.
So the second ones are the small numbers, like
Uh,
the times 2.
The blue is the smaller number, yeah. And that's why there's no blue on this line, because there's no small number on that V.
But then, what's the red?
The red is to
It's
make
just
the
a balance.
electrons lost equal the electrons gained.
Okay, so you only do blue if it's number on the left side.
I only did the blue because there's that little 2 there, and I don't have a blue here because there's no little number there.
Okay.
Okay, and then when you're done, you go science 10, looks good, except for hydrogen oxygen. Charges, neutral, neutral. Hydrogens and oxygens are actually balanced as well, so I'm done. And by the way, it's exactly how you could have done it in science 10. That's not the point.
Wasn't it 8? There's 5.
What, charges?
No. Oh
Are
yeah,
you
you have
adding-
to balance the charges.
No. What are you adding?
O's.
Oh, O's?
Yeah,
Because
it's
there's-
charged.
I've got 9, 10, 11.
Oh yeah.
I've got 5 and 6.
Simple math.
11. That whole adding thing.
I know, it always messes me up. I don't get everything else, and then I get the simple math wrong.
Often when you're teaching students algebra, they say 2 times 3 is 5. Like they forget the simple stuff when they're trying to juggle something really complex.
Yeah.
So that's what you're finding right now. You're juggling something really complex, and that means you kind of like can't even add it. Yeah.
Yeah.
Because your brain is
And then
fatigued
30
with the difficult stuff.
Yeah, I was just like, wait, what the heck? This isn't working.
Like 5, yes, 6 options, 1.
Okay, let's try 3 and 4 before the bell goes.
It works.
So then, Miss Brown, I can put it to either of those then, right?
Yeah,
So then, just
I'm
if
sorry.
I could put
It doesn't
this
matter
one, I
which
just
one
have
you
to
go
take
to.
into consideration the other one.
right,
Okay.
exactly.
Thank you.
Okay, so your heads down, working in partners or whatever you want on this, the 3 and 4. For the video's sake, I'm going to do it up and then stop the video and then we can talk about it. Okay? And you can have a sneaky peek if you need to. It doesn't matter which O you bring this bridge to. Okay? No. It doesn't matter which O you bring the bridge to. Because you're going to worry about it at the very end anyway. I just happen to bring it to the other molecule because it keeps things a little more ordered, different categories. But it totally doesn't matter, okay? Doesn't yesterday seem easy now?
H2O, because I know that's times 14.
So, Miss Brown, how did you figure out which one to use?
Just a second, okay? Let me finish
Yeah, no
this
problem.
question and then I'll...
So what's 14 minus 8?
No little things to balance by.
I can't go on. Is it a 5 for gaining?
Is it a 5 for gaining? Yeah, in total, down here? Because I've gone from 7 to 2.
Oh, you're looking at okay.
Science 10. My ions are balanced. My MNs are balanced. Don't balance hydrogen oxygen. So now charges. 1 plus +2, 5, +10. positive 15, that's positive 2. So on this side I have positive 17 total. So going back here, I've got positive 7, so I need, or 10 I mean, so I need 7 of these. Positive 17 charges. Huh? I've done something wrong, I've done something wrong, I've done something wrong. Oh, that's fine. It's this.
But she knows.
9.
Two.
8 of those. 8 plus 9 is 17, right, you
Yes.
guys? Thank you. So it's 8. It's not 8, 4. That's way better. I've done something right, I've done something right, I've done something right.
Could
What
you
did
just,
you get?
Okay.
oh yeah, that's before. Yeah, okay, there we go.
Okay, I'm going to push stop.